Let's look at the graph of the cotangent function. We'll follow the same model that we did with the tangent function, using the definition in terms of sine and cosine. So cotangent is cosine of x over sine of x. And I'm not going to draw those two functions, but I'm going to say that we know with the same reasoning as we did with the tangent function, when sine is equal to 0, we're going to get asymptotes. Now sine of x is 0 when x is 0. So I have an asymptote here on the axis. And when x is pi, and every pi after that. Okay, and then again, we have a point halfway between. At the places where cosine is 0, we have a point on the x-axis. Okay, then I'm going to talk about this in terms of quadrants. Between 0 and pi over 2, that's the first quadrant of the unit circle, if you think about that. And we're doing cosine over sine, both of which are positive. And so when we divide those, we're going to get positive numbers. So we're actually going to come up here and follow the asymptote up here to the left, the point. I'll point out again that halfway between the asymptote and that point, we're going to be up at 1, okay? Because that's when those two things are equal to each other. All right, and in general, that number is of course going to be the number in front of the cotangent function, like a vertical shift. Between pi over 2 and pi, that's if you think of the unit circle, that's in the second quadrant, where the cosine is negative and the sine is positive. So when we divide, we'll get a negative. So we're going to be down here, negative values, and our shape is going to be pretty much the same as the tangent shape, but it's just oh, that was not good. Whoops, down. So there's our sketch of the graph of just one branch of the cotangent function. And again, it repeats over and over again. So I'm going to go ahead and just copy it because I'm not super good at actually drawing smoothly, and that one looked pretty good. So I'm going to go ahead and just leave it like that. And it just repeats forever and ever, with those asymptotes occurring at every multiple of pi. So there's our sketch of the graph of the cotangent function. Now, again, this gives us a model to follow. When the input of the cotangent is 0 or pi, we'll get some asymptotes. And so that's how we're going to find the asymptotes of the cotangent function. In general, we have a times the cotangent of bx minus c plus d. And when this input, bx minus c, is equal to 0, or when it is equal to, that's a minus c, when it is equal to pi, we will get asymptotes. And of course, you just would then, once you got those two asymptotes, you just repeat with that same period to get more and more asymptotes. Let's go ahead and look at an example. Sketch the graph of y equals 2 cotangent of x over 3. So we start by finding our asymptotes by setting x over 3 equal to 0 and by setting it equal to pi. Well, multiplying both sides by 3, we get x equals 0, and over here we get x equals 3 pi. All right. Now, our graph here, we've got 0. Let's go ahead and sketch our asymptote there at 0. 0. And 3 pi is actually off the page here. It's going to be like way over here. So I'll go ahead and just mark that, and I want to draw that and make sure I get the full cycle of the cotangent function. And halfway between those, I have a point on the axis, which is going to be here at 3 pi over 2. And for the cotangent function, it's halfway between the left asymptote and that point. We're going to get that number in front. Now the number in front here is 2, So halfway between this is 3 pi over 4. We're going to go up to 2. And of course, on the other side, we're going to get down to negative 2. And then we want to kind of draw that shape, that curvy little shape. Okay. And of course, it's repeated on both sides. So I could do it again over here, and oops, right there. Kind of follow that. And there's our sketch of this function, 2 cotangent of x over 3.